Okay, so welcome to liquids and solids. First thing we're going to talk about are intermolecular attractions, which is the best name for it, or intermolecular forces, IMF for short. So this is between molecules. So if we have water, right there is a covalent bond. But if we have an attraction between molecules, that would be what we mean when we say an intermolecular force. These are much, much weaker than bonds and determine whether something is a solid, liquid, or gas at room temperature. So here are the types. We have dipole-dipole interactions, which is just simply, see the plus of this molecule attracted to the minus of that molecule. So it's the same concept as an ionic bond, but much, much, much weaker. And then we have hydrogen bonds, which are very important. They're a special type of dipole that only happens when you have hydrogen bonded to fluorine, oxygen, or nitrogen. So a very electronegative atom, that's your fluorine, oxygen, or nitrogen. Now, this is very important because it's important in water, organic, and biological molecules. So to remind you, organic means carbon compounds. And we're going to look at things like this molecule has no hydrogen bonds, whereas this molecule that has about the same molar mass can hydrogen bond. So when we are deciding whether something is a stronger or weaker intermolecular force, we need to look at molecules of approximately the same size. And the last intermolecular force we're going to talk about is London dispersion forces. And this is for nonpolar molecules. So this one here that I said did not hydrogen bond would have London dispersion forces. And how we need to envision this is that the electrons get tipped and we get an instantaneous temporary dipole. So the more electrons there are, the stronger the force is. So usually that means larger molar mass, stronger London dispersion, because a larger molar mass would have a greater number of electrons.